A wagon with a kid in it is being pulled with a force of 100 newtons, 30 degrees with the horizontal. First step is our free body diagram. Kid and wagon are a box because it's easier. The forces we have acting on this, well, we have the handle pulling, so that's our applied force. And they tell us that that's 100 newtons. They also tell us that that's 30 degrees with the horizontal. But we also have two other forces. We have the weight of the wagon and the kid, and we have the normal force, pushing back upwards. The mass that we've got dealing with is going to be equal to the 50 kilogram wagon plus the 30 kilogram kid. So that's going to be 80 kilograms. And I can figure out the components that we have here. My x component is going to be the force applied times the cosine of 30, and my y component is going to be of the sine of 30. And you can look back on those other slides if you want to. Since we're looking for acceleration, we know that everything's just going to be moving in the x direction, that nothing's really happening in the y direction, so we don't really need a y equation. So in the x direction, we have sum of the forces is equal to ma. And in the x direction, we really only have one force, and that is the x component of our wagon. And that's equal to ma. We're looking for acceleration, so that's the applied force cosine theta over m. That would be 100 cosine of 30 over 80. And that ends up being 590 newtons. Now, if we want in the y direction to write the equation just because, and eventually we'll have to when friction comes into the mix, we have a normal force going up. I'm going to make up be positive. So normal force going up, we have the force applied, sine theta going up, and then mg is going down, and that equals ma. And there won't be any acceleration in the y direction because it's not moving in the y direction.